The 2005 National Electrical Code Master exam preparation book generally covers most of the subject matter on the Georgia Master's exam, with the exception of the tax portion. The topics commonly addressed in the National Electrical Code Master exam include general electrical principles, electrical materials and equipment, electrical construction and installation, electrical safety, electrical calculations, and National Electrical Code requirements. Remember that the tax portion of the Georgia Master's exam isn't usually included in the National Electrical Code Master exam preparation book. For the tax aspects, you might need to explore other resources or consider a specific course. It's beneficial to explore additional resources for your preparation. The Georgia Electrical Contractors Association, also known as GECA, the National Electrical Contractors Association, also known as NECA, the International Brotherhood of Electrical Workers, also known as IABU, and the Electrical Training Institute, also known as ETI, are all possible avenues for more study aids, practice questions, and details regarding the Georgia Master's exam. Always verify the specific prerequisites for the Georgia Master's exam with the official testing authority. Requirements are subject to change over time, and you want the most current information. When preparing for any electrical exam, a strong grasp of fundamental electrical principles is essential. This includes understanding voltage, amperage, ohms, wattage, and the relationships between them as defined by Ohm's law and Watt's law. Being proficient in series, parallel, and series parallel circuits is key. You need to be able to calculate total resistance, current flow, and voltage drops in each type of circuit configuration. An understanding of alternating current, also known as AC, and direct current, also known as DC, circuits is also important, including concepts like frequency, phase, and power factor in AC systems. The course of study would include electrical materials and equipment. Knowing about various types of conductors, such as copper and aluminum, and their ampacity ratings is needed. Also, you will learn about different wiring methods, including conduit, cable trays, and direct burial. Different types of electrical equipment, like transformers, motors, generators, and switchgear, are part of the course of study. And overcurrent protection devices such as circuit breakers and fuses, and their application, must be understood. Electrical construction and installation techniques should be mastered. This includes proper methods for installing wiring and equipment in compliance with the National Electrical Code. Also, it involves understanding grounding and bonding requirements to ensure electrical safety and reduce the risk of electrical shock. You'll need to learn how to interpret electrical drawings and specifications. Furthermore, it requires skill in using electrical testing equipment, such as multimeters, clamp meters, and insulation testers for troubleshooting and verification. Electrical safety is paramount, so understanding safe work practices is required. This includes lockout-tagout procedures, personal protective equipment, also known as PPE, requirements, and arc flash safety. National Fire Protection Association, also known as NFPA, 70 standards for electrical safety in the workplace must be followed. Knowledge of the hazards associated with electricity, such as shock, arc flash, and arc blast, is critical. Also, first aid and cardiopulmonary resuscitation, also known as CPR, training are essential for responding to electrical emergencies. Electrical calculations are a cornerstone of electrical work. You need to calculate conductor sizes based on ampacity and voltage drop requirements, along with conduit fill calculations to ensure proper spacing and heat dissipation. Fault current calculations determine the interrupting rating of overcurrent protection devices. Motor circuit calculations, including branch circuit and feeder sizing, are vital for motor installations. Power factor correction calculations help improve the efficiency of electrical systems. The National Electrical Code, also known as NEC, is the ultimate guide for electrical installations. You will need to know how to navigate the National Electrical Code to find relevant requirements for specific installations. Understanding the National Electrical Code definitions and terminology is essential for accurate interpretation. National Electrical Code Chapter 3 covers wiring methods and materials, which is a fundamental part of the code. National Electrical Code Chapter 4 deals with equipment for general use, including receptacles, switches, and luminaires. National Electrical Code Chapter 5 addresses special occupancies, such as hazardous locations and healthcare facilities. The National Electrical Code is updated every 3 years, so always use the latest edition. Here are some specific examples of topics that you might encounter on the exam related to general electrical principles. Ohm's law dictates the relationship between voltage, current, and resistance. The formula is voltage equals current times resistance, or volts equals amps times ohms. If a circuit has a voltage of 120 volts and a resistance of 10 ohms, the current can be calculated as follows: current equals voltage divided by resistance, or 120 volts divided by 10 ohms, which equals 12 amps. Watt's law defines the relationship between power, voltage, and current. The formula is power equals voltage times current, or watts equals volts times amps. If a circuit has a voltage of 120 volts and a current of 5 amps, the power can be calculated as follows: power equals voltage times current, or 120 volts times 5 amps, which equals 600 watts. Series circuits are where components are connected end-to-end, forming a single path for current flow. The total resistance in a series circuit is the sum of individual resistances. If you have 3 resistors in series with values of 10 ohms, 20 ohms, and 30 ohms, the total resistance is 10 ohms plus 20 ohms plus 30 ohms, which equals 60 ohms. The current is the same through all components in a series circuit. Parallel circuits are where components are connected side by side, providing multiple paths for current flow. The reciprocal of the total resistance in a parallel circuit is the sum of the reciprocals of the individual resistances. If you have 3 resistors in parallel with values of 10 ohms, 20 ohms, and 30 ohms, the total resistance is calculated using the formula 1 divided by total resistance equals 1 divided by 10 ohms plus 1 divided by 20 ohms plus 1 divided by 30 ohms. Simplified to get the total resistance of approximately 5.45 ohms. The voltage is the same across all components in a parallel circuit. Alternating current, also known as AC, is electrical current that periodically reverses direction. In the United States, the standard frequency for AC power is 60 Hz, which means the current changes direction 60 times per second. Root mean square, also known as RMS, voltage is the effective voltage of an AC waveform. For a sinusoidal waveform, the RMS voltage is approximately 0.707 times the peak voltage. 3-phase power systems are commonly used in commercial and industrial applications. They provide 3 AC voltages that are 120 degrees out of phase with each other. Common 3-phase voltage configurations include 208 volts, 480 volts, and 600 volts. Direct current, also known as DC, is electrical current that flows in only one direction. Batteries and solar panels are common sources of DC power. DC voltage is typically constant and does not have a frequency or phase. Moving on to electrical materials and equipment, conductors are materials that allow electricity to flow easily. Copper and aluminum are the most commonly used conductors in electrical wiring. Copper has a higher conductivity than aluminum, but aluminum is lighter and less expensive. The ampacity of a conductor is the maximum current it can carry safely without overheating. Ampacity is determined by factors such as conductor size, insulation type, and ambient temperature. National Electrical Code Table 310.15 provides ampacity ratings for various types of conductors. Wiring methods refer to the way conductors are installed and protected. Conduit is a rigid or flexible tube used to enclose and protect electrical wiring. Common types of conduit include rigid metal conduit, also known as RMC, intermediate metal conduit, also known as IMC, electrical metallic tubing, also known as EMT, and flexible metal conduit, also known as FMC. Cable trays are open support systems used to support insulated electrical cables for power distribution and signal transmission. Direct burial cables are specifically designed to be buried directly in the earth without additional protection. Transformers are used to step up or step down voltage levels in electrical systems. Step-up transformers increase voltage, while step-down transformers decrease voltage. Transformers operate on the principle of electromagnetic induction. Motors convert electrical energy into mechanical energy. Alternating current, also known as AC motors, are commonly used in industrial and commercial applications. Direct current, also known as DC motors, are often used in applications requiring variable speed control. Generators convert mechanical energy into electrical energy. Generators are used as backup power sources during power outages. Switchgear is an assembly of electrical devices used to control, protect, and isolate electrical equipment. Switchgear includes circuit breakers, fuses, switches, and other protective devices. Overcurrent protection devices are designed to protect electrical circuits from overloads and short circuits. Circuit breakers are reusable overcurrent protection devices that can be reset after tripping. Fuses are one-time overcurrent protection devices that must be replaced after they blow. Grounding and bonding are essential for electrical safety. Grounding provides a path for fault current to flow back to the source, tripping the overcurrent protection device. Bonding ensures that all metal parts of an electrical system are at the same electrical potential, reducing the risk of electric shock. National Electrical Code Article 250 covers grounding and bonding requirements. Electrical drawings and specifications provide detailed information about electrical installations. Electrical drawings typically include floor plans, wiring diagrams, and panel schedules. Specifications provide written descriptions of the materials, equipment, and installation methods required for a project. Electrical testing equipment is used to verify the safety and performance of electrical systems. Multimeters measure voltage, current, and resistance. Clamp meters measure current without having to break the circuit. Insulation testers, also known as megameters, measure the insulation resistance of conductors. Safe work practices are essential when working with electricity. Lockout-tagout procedures are used to energize electrical equipment before working on it. Personal protective equipment, also known as PPE, includes items such as safety glasses, gloves, and insulated tools. Arc flash is a dangerous electrical explosion that can occur when working on energized equipment. National Fire Protection Association, also known as NFPA 70, provides standards for electrical safety in the workplace. Now some discussion on electrical calculations. Conductor sizes must be selected based on ampacity and voltage drop requirements. National Electrical Code Table 310.15 provides ampacity ratings for various types of conductors. Voltage drop is the decrease in voltage along a conductor due to its resistance. National Electrical Code Informational Note No. 2 to Section 210.19 AON recommends limiting voltage drop to 3% for branch circuits and 5% for feeders. Conduit fill calculations determine the maximum number of conductors that can be installed in a conduit. National Electrical Code Chapter 9 provides tables for conduit fill calculations. Fault current calculations determine the amount of current that will flow during a short circuit. This information is used to select the appropriate interrupting rating for overcurrent protection devices. Motor circuit calculations are used to determine the correct size of branch circuit conductors, overcurrent protection devices, and motor starters for motor installations. Power factor correction calculations are used to improve the efficiency of electrical systems. Power factor is the ratio of real power to apparent power. Improving the power factor reduces the amount of current required to deliver the same amount of power. And lastly, the National Electrical Code, also known as NEC, is the most important resource for electrical installations. National Electrical Code Article 90 covers the purpose and scope of the National Electrical Code. National Electrical Code Article 100 provides definitions of terms used in the National Electrical Code. National Electrical Code Chapter 3 covers wiring methods and materials. National Electrical Code Chapter 4 covers equipment for general use. National Electrical Code Chapter 5 covers special occupancies. National Electrical Code Chapter 6 covers special equipment. National Electrical Code Chapter 7 covers special conditions. National Electrical Code Chapter 8 covers communications systems. National Electrical Code Chapter 9 contains tables and examples. The National Electrical Code is updated every 3 years, so it is important to use the latest edition. When using the National Electrical Code, it is important to understand the definitions and terminology used in the code. National Electrical Code Article 100 provides definitions of many common electrical terms. National Electrical Code also uses specific terms to indicate mandatory requirements. The word shall indicates a mandatory requirement. The word shall not indicates a prohibition. Informational notes are provided to give additional information about a code requirement. Informational notes are not mandatory requirements. Examples are provided to illustrate how to apply code requirements. Examples are not mandatory requirements.